Oh, hey, you guys. Here is the limiting reactants and percent yield worksheet, and we're looking at number 1, which I think is a good example of the kinds of problems you'd see for this unit. In this problem, we've got this compound iodine 5-oxide reacting with carbon monoxide to make carbon dioxide and iodine gas. And it's saying we got 80 grams of the iodine 5-oxide, and we have 28 grams of the carbon monoxide, and part A is saying how much iodine, how many grams of iodine can be produced. So it's kind of a two sort of pronged approach where you have to figure out how much of this is made first by what runs out first. So you take your 80 grams of the iodine 5-oxide. We're going to convert that to moles of iodine, and then take your 28 grams of carbon monoxide and also convert that into moles of iodine. The molar mass of this one, let's see, is iodine 126.9. There are 2 of those and 5 oxygens, so it's 333.8. And we're going all the way over to iodine. It's a 1-to-1 ratio. One of these produces 1 iodine. So 1 I2O5 gives us 1 iodine. Do the same for the carbon monoxide. The molar mass of carbon monoxide happens to also be 28 grams. And that is a 5-to-1 ratio. 5 of those will produce 1 iodine. So 5 carbon monoxides, 1 iodine. And then you're going to get 2 numbers. First one, 80 divided by 333.8 is 0.24. And the second one is 28 divided by 28 divided by 5, 0.2. So they're close, but the smaller one is the one you want. So this one is too big, and that means that carbon monoxide is your limiting reactant. It limits how much you can make, which I think is part. Oh, no, this doesn't actually say what one is the limiting reactant. It just says how much is produced. So we take that limiting reactant now, and we convert that into grams. So we know we're going to make 0.2 moles of iodine, but how many grams is that? Take your 0.2 moles and multiply by the molar mass of iodine. It's I2, so you got to double it. So 126.9 times 2 is 253.8, and multiply that by 0.2 here in this problem, and you get 253.8 grams of iodine, 1 mole, and your answer is 50.76 grams of iodine. So that's the answer to part A. How much do you make? And it's all based off this number, based off of this number of moles, because the carbon monoxide runs out first. Okay. In part B, you've got, so like this is an actual number, so it's only 0.16 moles are produced, or actually produced, and so that is going to be the key to doing this percent yield problem. So what mass of iodine is produced? So take the number in part B, and this is 1, and it says what mass of iodine was produced? Well, it's 0.16 moles, and multiply that by the same number, 253.8 grams per mole. So 0.16 times that gets us about 40.61. This is your actual yield. Just given to us in moles, so we just convert it to grams now. And then what the percent yield is your actual over your theoretical. So the 40.61 divided by what we were supposed to make. And what we were supposed to make was the 50.76. And then multiply that by 100 to find the percent. Take this divided by 50.76 times 100, and you get, not good at numbers, sorry. 0.8, well, 0.8 times 100, guys. We all know it's 80%. And that's your percent yield for the problem. So a good example of the kinds of problems you'll see on the rest of this worksheet. Best of luck. Okay, bye.